So this question here, we've got a transformation w equals 3z over 2z minus 1, and it transforms from the z plane to the w plane. In complex analysis, this question's all about. The line y equals x over 3 maps to a circle in the w plane using this transformation. That's what we want to try and show. And what we're going to look for is to find the centre of that circle and the radius of that circle. So let's get straight to work on this and do some algebra on this. Now, when we got a transformation, our first job is to get z out of this side of the equation on its own. So we're in terms of w, now let's get it in terms of z. So first of all, let's multiply both sides by 2z minus 1. So we've got w 2z minus 1 equals 3z. Now let's distribute the w inside of here. So now we've got 2wz minus w equals 3z. And now let's bring this 3z over here and bring this w over to this side. So now we've got 2wz minus 3z equals w. And now we can factor out the z from that. So now we've got z 2w minus 3 equals w. And now simply divide and we get what z is. So z equals w over 2w minus 3. So that's what we got so far. Okay, now next stage, what can we do next? Well, z is in complex analysis and w is in complex analysis. So let's define our complex variables z and w in terms of that. So let's do that on here. So look, z equal x plus iy. So x and y are real numbers. X is the real part, y is the imaginary part. And then let's do w similar, but using different variables. Obviously it's a different number. So we use u plus iv. So u again is the real part of w and v is the imaginary part of w. So what we're going to do now is transform that into there using these parts of our complex number. So z equals x plus iy. So we've got x plus iy equals w is u plus iv and 2w minus 3. So it's two of those minus 3. So we've got 2u plus iv minus 3. Okay, that's a 2. Okay, right. Now let's simplify this off and let's see where the algebra takes us. So x plus iy then equals u plus iv over 2u. Now that's the real part, that's the imaginary part. 3 is obviously a real part as well. So let's bring the 3 in with the 2. Let's invite that in there and then put that in a bracket. And then we've got 2 times iv, so plus 2iv, so plus I 2v. So that'll be fine like that. We know it's the complex part. Okay, now what can we do with that? We want to try and do something with this x plus iy. So we want to show the line y equals x over 3 using this. So we want to try and get some real terms and imaginary terms in here and the same here. So our next thing to do is to get rid of this complex number in the denominator. So the easiest way to do that is using the complex conjugate. So if I multiply this by 2u minus 3 and then minus I 2v and then divide that by itself, so I'm effectively multiplying by 1. Hence we don't change the value of anything. So now I've got x plus iy equals. So now let's deal with the denominator. So as it's a complex conjugate, I want to get rid of this imaginary part. Plus I times minus I will give me plus 1, because I squared is minus 1, and I'll have another minus. And then I'll simply square 2v, which is 4v squared. So then my denominator will be 2u minus 3 squared plus 4v squared. So it takes care of that. And now I've got to distribute each of these with these. So let's deal with the u plus iv with 2u. So 2u times u will give me 2u squared. And 2u times iv will be plus 2uv I, imaginary. So plus I 2uv. So that's that one distributed with the 2u. Now the minus 3. So I'll have minus 3u and minus 3 iv. So minus I 3v. So that takes care of that. Now let's distribute this with each of these. So minus I2v times u, that's minus I2uv. So that takes care of that. And then multiply that with the iv. So again, minus I times I will give us positive 1. And then 2v times v will give us plus 2v squared. Okay. Right, now let's bring that up here and simplify this off a little bit. Let's see what we can do. So now I've got, let's draw a line down here. X plus iy equals 2u squared plus 2v squared. That's working quite nicely. So that's my two square numbers. So that's them done. Let's just tick them off as we do them. And I2uv minus I2uv, so they cancel out. So that's good news. When you're dealing with conjugates, that usually happens, so that's good news. And then I've got minus 3u, so that will come into there. And minus I3v, so that's my only complex part. And then the denominator, I've got 2u minus 3 squared plus 4v squared. Okay, right. Now that's as far as I could go with that, I believe, for now. Now what I've got is I want to map this onto the line y equals x over 3. So x equals 3y. That's what we've got from there. So what I should do now, I should have a real part and an imaginary part. So my real part is this bit, and my imaginary part is this minus I3v. So my x should correspond to this, and the y should correspond to that. So if x equals 3y, where x equals, so if I write that out, x equals 2u squared plus 2v squared minus 3u. So that's what my x is with the denominator. Let's just put that in there for now. You'll see good things will happen there in a moment. And then that should equal 3y. So if I just put a bracket in there, 3y. Well, my y is my complex part, should equal 3 of those. So that should equal minus 3v times 3. So that should give me 9v. And then I keep my denominator, 2u minus 3 squared plus 4v squared. Okay, let's just keep that away from our terminology there. So as these are equal, we can now discard the denominators because they've both got the same denominator. So therefore x equals 3y. So this is my 3y. So as they are equal, I can bring them over to one side and set them to 0. And then good things should happen then in terms of finding my circle. So now let's just write this over here. I've got 2u squared minus 3u plus 2v squared. So if I write that like that, that's going to help me get my equation for the circle. And I've got minus 3v times 3, which is minus 9v. Notice I lost the imaginary part because y is the imaginary part. So that's the actual I value gone. So now minus 9v, I can just add 9v to this side and set that to 0. Okay, right. Now what can we do to try and find the equation of a circle? Well, I've got my u's together and my v's together. That was kind of my technique there to try and make it easier for myself. So I'm going to try and find squares in there now. So if I take the 2 from the u squared, and then I write u minus, now I want to turn this into a square. Now I've got to put something in here representing the 3u. Now I've already taken a 2 out, so I'd have 3 over 2. But as I'm going to square it, I want 3 over 4. So 3 over 4. And then square that. And now I need to put in a magic number to allow for multiplying by this and multiplying this out, because I will gain now 9 over 16 by multiplying that out as a square. So I now need to subtract 9 over 16, but I've multiplied by 2. So I need to subtract 9 over 8. So 9 over 8. So that takes care of that. Now let's do the same with this v variable. So now I can add. So if I take the 2 out and put the v plus, and I'll start off with the 9. So I've already multiplied by 2, so I then need to halve this. And then as I'm going to try and square it, I need to halve it again. So it's plus 9 over 4 squared. And then my number I need to subtract from, because I've squared this, so that'll give me 81 over 16, but then I've times by 2, so that'll give me 81 over 8. So subtract 81 over 8 and set it to 0 as before. So now I'm nearly there in finding an equation for a circle. So I've got 2u minus 3 over 4. So 2u minus 3 over 4 squared. These constants I can bring over to the other side. That'll give me my radius. Let's repeat this one. That'll give me my y coordinate for my circle centre. V plus 9 over 4 squared. And then minus 9 over 8 minus 81 over 8 is minus 90 over 8. Minus 90 over 8 is minus 45 over 4. Bring to the other side, I get positive 45 over 4, which is really important. So if I take the square root of that, that's going to give me my radius.